Greetings class, this is your sub 15-minute mini lecture on chapter 3, and we're going to focus our attention on the digestive system. I'm sure most of you heard the expression, you are what you eat. Well, nutritionists would argue it's not you are what you eat, but you are what you absorb. As we ingest food, really the nutrients that we get or derive from those foods are contingent upon our ability to break down those large food particles into smaller chunks and pieces that we can digest and absorb. So digestion is the process of taking big pieces and making them into small pieces in order to prepare them for absorption, and then ultimately we can utilize those nutrients. So digestion begins in the mouth with both mechanical and chemical digestion. The motion of our teeth chomping on the food is what we refer to as mastication, and that's a form of mechanical digestion. We also have chemical digestion in the form of saliva and the different enzymes, more specifically salivary amylase, that is released by the salivary glands. That salivary amylase is actually going to initiate some carbohydrate digestion in the mouth. Very little with respect to digestion is happening in the esophagus. That salivary amylase that was secreted in the mouth may still function to a slight extent, but the esophagus basically is just a conduit from the mouth to the next organ of the gastrointestinal tract, that is the stomach. The food bolus will move using peristalsis, which is involuntary smooth muscle movement. Okay, it's muscle movement, but it's not the same type of muscles that you use to do a bicep curl or a shoulder press. Those are skeletal muscles. The muscle that's in the esophagus is called smooth muscle, and it's involuntary. We don't have to think consciously when we eat food about contracting that muscle to move the food down to our stomach. It happens on its own. At the top of the stomach sits a muscle called the lower esophageal sphincter, and that muscle acts as a lid or a cap. Kind of think of it as a cap on any type of water bottle or soda bottle beverage container. Just like that cap is designed to hold the contents of the fluid inside the bottle, the muscular flap, the lower esophageal sphincter, is designed to hold down the contents of the stomach so it doesn't come back up and go into the esophagus where it will cause heartburn. Okay, the stomach is approximately, or holds approximately 1 quart, which is equivalent to 4 cups or 1 liter. Now that's an average size. Based on the individual, it will vary slightly. Think of the stomach as a holding tank or a reservoir. The way that it's shaped is that it has a slight cant to it. So food is going to remain in the stomach for several hours so that chyme can form and so that all the gastric juices that are released, which includes stomach acid, can act on the food that we've ingested and start some digestion. So the stomach does churn a little bit. So there's some mechanical digestion as well. That stomach acid that is present would ordinarily burn through something like an organ like the stomach, but the stomach has a thick mucus coating that prevents that autodigestion. And usually when you look at as a diagram as we are here, you don't see, for whatever reason, most textbooks I've ever seen, they don't show that thick mucus coating, but it does exist on the inner lining of the stomach, and it prevents the stomach from self-digesting it. Okay, stomach acid, has an important role of initiating digestion. It also is not listed here, but is the first line of defense for the immune system. If you ingest some type of microbe or pathogen that might make you sick, your stomach acid is going to attempt to destroy that. Okay, if we didn't have that stomach acid, we would probably have much more issues of foodborne illness. So that stomach acid is important to destroy and kill off any harmful bacteria that we might ingest unknowingly. Okay, we've talked about peristalsis. Okay, we come to the small intestine where the majority of digestion and absorption will occur. There's a small amount of alcohol absorption in the stomach, but outside of that, very little, or rather no absorption really taking place. All the absorption is going to happen, for all intents and purposes, in the small intestine. Now, unlike the other features that we've talked about, the small intestine, the inner lining is unique. It's not a smooth tube, but rather there are different structures, mucosal folds, which increase the surface area, as well as the villi, which are tiny finger-like projections, and then microvilli as well, which kind of resemble cilia. These increase the surface area of the small intestine by 600-fold, and it's estimated that if we were to spread out all that surface area, it would cover a tennis court. So pretty dramatically, even though it's called the small intestine, it is a dramatically large organ. Let's see, we're going to skip over these absorption slides and we'll talk about the large intestine. Now, the large intestine is responsible for collecting essentially waste material and preparing it for excretion. There is some absorption of primarily of water and electrolytes. So when people are sick and they have diarrhea, the common recommendation is to replace fluids and replace electrolytes like salt and potassium, and that's because the losses are so great during that type of illness. There is also a tremendous amount of friendly bacteria in our large intestine, anywhere from 8 to maybe 10 pounds worth. So a tremendous mass of bacteria exists in our large intestine, which helps to keep our body, our intestines and our entire body healthy. If you are taking antibiotics, which are oftentimes broad spectrum, because you have a bacterial infection, well, that's good for getting rid of those unwanted bacteria. The problem is that those antibiotics will also indiscriminately kill off this friendly bacteria that exists in our colon, and that's something that's undesirable. So it's a good time then to consume some foods that have friendly bacteria, such as yogurt. If you don't like yogurt, it might be a good time to invest in some friendly bacteria capsules that you can take concurrently with your antibiotic treatment. Okay, so absorption in the small intestine, remember that's the major organ that absorbs nutrients. I want you to understand that there are different absorption sites for vitamins, minerals, and macronutrients. They're not all absorbed at the same place throughout the entire small intestine. Lastly, we have the rectum, which is where we excrete our waste products in the form of stool, and this is important to have regular bowel movements, as we'll talk about here before I close. Otherwise, there can be some undesirable side effects from that. Now, 3 accessory organs play a role in the digestive processes, and those are the pancreas, gallbladder, and liver. The liver stores, or rather produces, bile that it then sends to the gallbladder, which stores it. Okay, that's one of its main purposes, is to produce bile that is then delivered to the gallbladder, which will store the bile. The pancreas is responsible for releasing pancreatic juices into the small intestine, which include a variety of digestive enzymes, which we'll learn about when we get to those chapters 4, 5, and 6 covering carbohydrates, proteins, and fats. The pancreas also produces hormones, notably glucagon and insulin, that are involved in blood glucose regulation. And also, as part of the pancreatic juices, we have bicarbonate. Now, earlier we talked about stomach acid, and that exists in the stomach. Some of that stomach acid will invariably get passed down into the next organ, the small intestine. So we need a way to manage that acid or buffer it. And so the pancreas secretes bicarbonate, which is a base that negates that low pH of the stomach acid. And that's good because just like the esophagus, the small intestine also does not have a mucus coating. Okay, common problems with digestion. Let's take a peek at just a couple of these. Heartburn it occurs when the esophageal sphincter, which is a muscle, becomes weakened or relaxed over time. You can avoid heartburn by oftentimes, or rather you can treat heartburn by avoiding the foods that may aggravate it, which are different for every person, but spicy foods, tomato products, garlic, onions, coffee, in some cases tea, alcohol. Those are, all common culprits that seem to trigger heartburn, but it's different for each person. You should also be aware that peppermint is a muscle relaxant, and so if you have heartburn, you shouldn't drink peppermint tea to soothe it, because you'll only actually exacerbate the condition by relaxing the esophageal sphincter. You should also chew your foods very well and try to eat slowly and not lay down after eating, because staying upright allows gravity to work in your favor and helps to facilitate that peristalsis. Okay, constipation occurs when we lack dietary fiber in many cases, or fluids, and are not regularly physically active. So if we add back those missing components, we can effectively diminish constipation. Sometimes constipation is caused by medications, especially painkillers, slow down the movement of, or gastrointestinal motility, the movement of food through the gastrointestinal tract, particularly the lower part. And so pain medications can cause constipation as well. And that covers the slides that I wanted to make sure I expanded upon in this time that I had. There's one more gastrointestinal condition that actually is in Chapter 4. It's known as diverticulosis. And so when we get to Chapter 4 here in the next week, we'll talk about that one. So I'll see you next time. Thank you.